let me show you guys something that's really strange. So here, you're told that y is inversely proportional to x, and here z is proportional to y squared. So let's try and summarize this. So y is inversely proportional to x. So hang on, y is inversely proportional to x. Okay, so you can summarize the first part as this here, and then in the second part, z is proportional to y squared. So here z is proportional to y squared. So here you've been given two statements here, but the thing is there's a connection in between here. So it's just like me saying this here. If A is proportional to B, and then somewhere else I would say B is proportional to C, then you see as A goes up, let's say you times it by 2, this gets timed by 2 as well. Well, then that means this gets timed by 2. So this will mean it will get multiplied by 2. So here you've got two separate statements here, but then you can actually say that A is proportional to C. Okay, so from these two we can deduce this. Okay, so now it's the same thing over here. Wait there. So here, y here is inversely proportional to x, and here we've got z is proportional to y squared. So somehow we've got to connect the two statements to get it in the form of z is proportional to whatever involving x. Okay, because the question is saying find the relationship between z and x. So we want z equals a constant involving k. There's a connection between z and x. Okay, so hang on, let's start again here. So summarize the first part. Y is inversely proportional to x. So y is inversely proportional to x. That's the first part done. The second part, z is proportional to y squared. So z is proportional to y squared. So the minute, this here is the second statement. The minute we've been given this here, we can visualize this. Y equals a constant over x. Okay, and then well, we are here at the moment. How do we get from here? Well, you see, this is for y. We want to somehow get to y squared. So well, if when we get given this, we can jump to this, then let's square both sides here. So if you square both sides, so it will be y squared equals k squared over x squared. So we are squaring both sides. You see, when you are here, it's just like a fraction times by itself. So when you have a fraction times a fraction, top times top, that's why you've got k squared here. This times this, that's why you've got x squared at the bottom. Well, anyway, we started off here, we jumped to this, and then we can get to this. Okay, now look at this. We've got the y squared here, and then here we've got y squared here. Well, we can actually put this into this thing here. Okay, so look at this. Hang on. So now we've got z is proportional to some sort of number here over x squared. Okay. Well, you see, when we're here, we can immediately jump to this. Z equals a constant y squared. But then you see, this is the equivalent of y squared. So we can actually put this into this y squared. Don't forget, this is already y squared. Okay, this is already y squared. So we can put it into here, into the whole thing here. So it will be this. Z equals a constant, a number that we don't care about. So this is this k here, okay, and then we've got to times it with y squared. Hang on, we've got to times it with y squared, so it will be this k squared over x squared. You see, this k here is a number that we don't care about involving the y here. This k here is a number that we don't care about that was connected to the z here. So you see, you've got a number that you don't care about here and another number that you don't care about here. Really, we shouldn't use k because it gets confusing, but because we don't really care about these two numbers here, these two numbers don't change, they're constant. So let's merge them. We don't really care about them. So hang on. So even though you've got hang on. Even though you've got a k squared up here, hang on, let me just tidy this up. Hang on, z equals, you've got a number that you don't care about here times a number that you don't care about squared. Well, anyway, we don't really care about this. No matter what it's in there, we don't really care about it. We could call it m. Okay, let's just say it's a constant m. But I don't really want to call it m. I'm going to call it k. It's just a number that we don't care about. Hang on. It's just a number that we don't care about. So that k squared thing there, it's like a number. Let's say 0.7 blah 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 here. Square it. Well, when you square it, you're going to get another new number. I don't really care about that number either. And then here you've got this number which you don't care about times in this k squared, or we can just imagine as k without the squared. Okay. Well, you got a number that you don't care about times another number you don't care about. So let's just call it k. Let's just merge it. Yeah, they're gonna. Don't forget, this new k here is different from this k. It's different from this k. But because when they merge together, we don't really care about whatever that number is. Let's just call it k. Okay. So this one here, it will be x squared. Okay, so z here equals this. Now, when you get given this, z is proportional to so z is inversely proportional to x squared. You can jump. When given this here, you can immediately jump. Oh, sorry. You can immediately jump to z equals a constant over x squared. Okay, so when given this here, you can jump to this. But now we are here at the moment. You see, these two are the same, so we can work backwards and jump back to this. So when we are here, we can work backwards and jump to z is proportional to sorry, z is inversely proportional to x squared. So it's just like when we're here, it's just like we are here, but we are working backwards now. Now we can say this statement here. So overall, z is inversely proportional to x squared. Okay, so that's your answer.